So let's take a look at what we did last time. I'm going to go ahead and hit play. I forgot to save it actually. Let's grab our cylinder blueprint here. And what we can do, and this is, if you're in my class, was your assignment. Um, we can make a little duck game, sort of like these circus games. So let's hit Control W to duplicate this. So we have our carnival game here. So this is what we have last time. So you press play. Alright, so let's take a look at what we can do next. What we're going to do is adjust the character controller. Take a look at that, the component they give us here, and how we can add some additional attributes to it. So inside of the blueprints folder, just go ahead and double click first person character blueprint. And let's take a look. There seems to be a lot going on here, but it's a lot easier than you might think. So let's just start off with the stick input, because we're not really going to be looking at motion controllers or VR stuff. And let's dock this up here. So I'm going to be tweaking that. Let's move some of this stuff out of the way. So some things to take note of is the red nodes, these trigger nodes, they run at every frame and they pass the values, for example, like turn rate here and lookup rate, and so you can see here's base lookup rate from the controller input. And these values are commonly mapped to the left and right axis of your thumbstick, the analog stick that's on your PS4 or your Xbox One controller. Then the values from those triggers are multiplied by a variable. You can see that here, representing it's the rate in which the player is like intended to turn, look, or turn around or look left and right. And then those values are multiplied by delta time, which is what we did last time. You can see that down here. So you can see here's your axis, here's our get world delta time. So below this input we have the mouse input. Here, let me zoom in a little bit better so you can see here. It converts input from your mouse, and this is opposed to the controller axis. And it converts it just pretty much for all the other movements. So you can see here input, look up, turn, your left, right, and your forward. It doesn't really do a rotation. If you rotate your mouse, it really doesn't do anything. So let's take a look at customizing this. Let's go back to our first person controller here. Go to Edit, Project Settings, and off to the side here, look for Input. So under the Engine section, you'll see something called Bindings. And there's two categories, Action Mapping and Axis Mapping. Action Mapping is used for key presses and mouse clicks, pretty much events that trigger player actions. Axis Mapping, which is this guy down here, is meant for mapping player movement and events that have a range. So if you push the W key or the S key, it moves the character forward and back, but on different ends of the range. So let's start off with our action mapping here. You can see we have jump, fire, reset VR. We're going to press plus twice, and it gave us two new action mapping functions. What we want to do for our first one is we want to add a sprint. So I'm going to name this sprint. And then when you click on this, it's going to give you these different inputs. So if we go to keyboard and we expand this, you'll see we get all of our different keyboard inputs. I'm going to do left shift. And to help our game out a little bit more, our duck shooting game, I'm going to name this zoom. And I'm going to map this to my right mouse button. So go ahead and click this, look for mouse, and then we want to do right mouse button here. Alright, let's maximize this to make sure that we've got everything in place. Okay, let's close that out. It takes our minus 10 and it converts it to a steady value. Let's start with our sprint ability. So go ahead and go up to your first person character here. So let's go ahead and drag this out and then name it normalize. All right, so up here, I'm going to create a
there's
new
our
set of
this
nodes.
is pretty
So
simple
we want
function
to
that'll
get
normalize it
that
for us.
sprite input that
So
we
the
just
next thing we
created.
need to
So
do
I'm going to
is
right click in here
do
and I'm
this
going to
by
type in
delta time.
input
Now,
and sprint.
if you think about frames per second
There it is.
as it relates to
Let's zoom in a little
video
bit on
games,
this.
now
Now,
you might
just
have
so that
30
we can,
frames per second, you might have 120,
just like
and
they
oftentimes
commented
they
here,
allow
I'm
you
going
to
highlight this
adjust
and
the
I'm going to hit
quality
Control C. Or I'm sorry, just
within
the
the
C
game
key.
because based on the video card, you
for
get a
my
different frame
comment, I'm going
rate.
to type in
What delta time
sprint
does is it normalizes the frame
input
rate
or something like
based
that.
on whatever
You
the
could always
current
change our
time
comment
is of the
later, and then you can
system
adjust the size
and
of a comment by
the average of
moving this around.
the memory based on the
Now,
the
our
video
character
card.
itself has a
So
speed
what we're going to do
component,
is
and that's
grab
what we want
speed
to edit
from
when we
here,
hold shift. So I'm going to drag this out
and we
I'm
want to
going drop
multiply
it here.
this by delta time. So I'm going to right click up here.
Now,
I'm going to type
something I
get
want to point
world
out is if you notice anything that says inherited at the end, see it says source at the
delta
bottom,
in
inherited from
seconds,
C++.
and we
This
want to
is a
multiply
script
these
that
by
was
30.
actually
So I'm
written
just
in
going to
C++,
right click
and
and
most of that
type
stuff,
in
all the
MUL,
heavy lifting with physics calculations and stuff related to
and
movements is
let's
usually written in
multiply.
C++, and then later we can take it into a movement. So we can actually
So we
edit
can
this
just
in the
drag it
header
out
file.
here and do multiply this
Alright,
way.
so let's go ahead and drag this out, and we're going to look for max walk speed. You can see there's set max walk speed, and we're just going to get it.
We'll do float by float. Let's try that.
You can
float.
see, I just want to show
There
you
we go,
this, that
times
the default
float.
value of this is 600.
And then let's
So if we
multiply
delete
that times
this
our
and we
speed, which is a
go
float.
to set walk
So now what
speed,
we need to do is take these two values and multiply them by the current location. So what this static mesh component is referring to is the
adjust that
actual
600 value
cylinder in
inside
our
of here.
scene.
So if we
So when I
grab our
drag this
pressed
out this way,
node and we connect it here, now when we press our left key,
so
we'll
what we
access
want to
this
do now
walk
is
speed.
get the world location.
I'm also going to
I'm gonna
change
drag
this
this
to
out. I'm going
2200
to type
because
in get
if our walk is 600, we want
world.
it to really sprint at 2200.
So we'll do get world location.
So we also want our character to slow down.
Or we can
so
do
I'm going to grab out
get
another
world
set
transform.
walk speed from
So
here.
what this is going to do is get the current position or transform position of our static mesh component.
And what's going to happen is when we release
We don't want to
our
affect
left
the
mouse
rotation because we want it to go back and forth.
select it
So the
in
next
here.
thing we want to do is break down the
once it's
transform
pressed,
into
it'll
its
shoot
X,
up
Y,
to
and Z.
2200, and once
So
we
I'm going to grab
release
this,
it,
and there's a break transform,
it'll transition slow down,
which is here. So
to
here's
whatever
the
the walk
location,
speed is that we
rotation,
put
and
in here.
scale.
So I'm going to go back down to the default 600.
Zoom this
our
out a little
walk
bit so you
speed.
can see this.
All right, so let's select this and make sure that
So let's go ahead and just sort of,
everything is
I'm
inside
going to
this
put
comment
this
box.
over here.
Kind of move these guys.
I'm just sort of
down a little
lining
bit
these
too.
up.
All right, I'm going to
Move this off
compile
to the side
this.
to give us some
I'm
more
gonna,
space.
save it and press play. Now, if I
All right.
move forward with my arrow keys and
The
I
next
hold
thing I
shift,
want
you'll
to
see
do
he
is grab my
sprints.
make
So
transform
here's his
node.
normal walk speed, and now he sprints.
You'll notice here that this has the location, rotation, and scale. So all I have to do is grab location from here, rotation from here, and scale from here. And what we're doing is we're getting all of those things from our static mesh component. So next we need to multiply the direction of the vector and the speed. By multiplying those two, it'll give us the speed in which it's going to move. So we're just going to we're going to grab our normalize from here. And we're going to do the same thing. We're going to drag out a float by float. So float times float. So I'm sorry, vector times float here. Boom. So there's our vector, and then we're going to drag our float going this way, and I've kind of position these something like this, just so they're not all tangled. So you can see there. Let's move this back a little bit here. Now all we have to do is add the speed and direction to the current location we're at. So imagine that you're like sort of moving an object across by whatever the value is, as it's adding it, and that's what's going to actually move it. So if we, remember, this is an x, y, and z. Each one of these has x, y, and z values. So we want a vector plus a vector. And here's vector time. So let's just do plus. Vector plus vector. Let's move this up here. And then what I'm going to do is take this location node and put it here. So now we're adding these two together. And then the location itself is going to be coming from this guy. So you can see here that here's our direction and speed. We're multiplying these two together, and we normalize it. And then that normalized value of the direction we're multiplying, then we add that to the current position that our mesh is in, and then our make transform is what combines it. Now we don't remember before that we created a event hit here. Now we need an event to actually make things move. Before there was three. One of them was event tick. I didn't really go into detail, but event tick actually runs or ticks every frame. So we're going to be using this to move to run the blueprint that we created earlier on every frame to move our object. So let's put this up here, and then the last thing we're going to do is set actor, and what we're setting is the transform. So set actor transform, and you can see here that it has new transform. It just means the new position, and then this is what's going to fire it off. Go ahead and compile it and save it, and what you'll see now, here I'm going to kind of drag this out a little bit. Hopefully you can see that. You can pause it and hopefully use that as a guide. But what it'll do now is it'll move in the left direction when I press play. You can see that it's moving on its own. There's only one problem. We need it to move back and forth. And we're already at the 11-minute mark, so we'll do that in the next video.